All right, welcome to our 9.2 video. We are continuing to talk about quadratic functions. For the opening problem, we're just going to look at a real-world example of what a parabola can model. So if you read this, it says you throw a ball straight up into the air and catch it at the same height you released it. So this parabola is modeling the height of the ball in feet after a certain amount of time. In this case, it's seconds. So this isn't what the ball looks like when it's thrown. It's over time, how high is the ball. So for the total distance the ball travels, we're talking about it's going up and back down. Up and back down. Okay, so it's starting at 0, 4. So that means you're holding it probably about 4 feet above the ground. You throw it up in the air. The maximum height it reaches is 20 feet. And then by the time after 2 seconds have passed, it's back in your hand at 4 feet. So it says, for how long does the ball travel up? Okay, that is until it stops at your maximum point. So it's rising right here for 1 second, falls for another second back into your hand. So parabolas often model real-world situations such as this one, or once again, the ball was being thrown up in the air. This does not model what that looks like, but rather its height over time. So one more time, you're starting holding the ball 4 feet above the ground. You throw it into the air, and after 1 second, it's at its maximum height, and after 2 seconds, it has fallen back into your hand at 4 feet.
Okay, we're going to add something in different today. We're going to add a b term to our quadratic function. Notice, remember yesterday we had ax squared plus c, and c affected how our graph was up or down on our coordinate. With the b now, you can see on 3 examples here, we are going to be adjusting our parabola left and right on our coordinate graph now. All 3 of them still have a 0 for our c, so you can still see they cross the y-axis at 0. But they have a b term now, and that's adjusting how our parabola looks left and right. In order to find that x coordinate for our parabola, we are going to plug in the formula x equals negative b over 2a. Again, that will give you your x coordinate for your vertex on your parabola. So in the third equation, you're going to plug in, since b is 6, you're going to do a negative 6 over 2a. And again, remember that it's negative b, so it's the opposite b. So if b happened to be a negative, we would change that to a positive. So it's going to be negative 6 over 2 times 2, which is negative 6 over 4, which then simplifies to negative 3/2. And again, that is going to be our coordinate for our x-intercept, or I'm sorry, our x-coordinate for our vertex. And then in order to find our y-coordinate, we're going to plug that value back into our equation of the 2x squared plus 6x, plug that back into our x, and that will give us our y-coordinate for our vertex. So when you substitute x equals 0 into the equation, that will also give you your c, or y equals c. So the y-intercept of the quadratic function is going to be your c. So you can use the axis of symmetry and the y-intercept to help you graph that quadratic function.
All right, so now we're actually going to practice graphing this. We are going to go through the steps listed here. Those of you that have a graphing calculator, we will talk to you in class about what you can do to speed up this process, but go ahead and go through the steps with us now so you have an understanding. So the difference from how we graphed the other day is that our vertex is no longer going to be on the y-axis. Because we do have a b value here, that affects the graph, as Mr. Isles said. So you have to actually use this equation that we just talked about to find the x-coordinate of your vertex. So using these values, we all know how to identify a, b, and c. So the number in front of your x squared is a, which in this case is 1. B is negative 6, and c is 4. So using this equation, I'm finding the x-coordinate of my vertex. I would take the opposite of b. It's like you're taking negative 1 times whatever your b value is, which mine is negative 6. On the bottom, I will be taking 2 times a, which is 1. So the opposite of negative 6 is positive 6 here, over a 2, which gives me x equals 3. So x equals 3 is the x-coordinate of my vertex. But notice coordinates, they are a point. So I don't only need x, I need y as well. So I will take this x value of 3 and plug it back into my original equation to find y. So in this equation up here, now I'm going to plug in a 3 every time there's an x. So 3 squared minus 6 times 3 plus 4. So using your order of operations, this is 9 minus 18 plus 4. So 9 minus 18 is negative 9 plus 4 is negative 5. So my point for my vertex then, x was 3 and I found y to be negative 5. So going over to my graph, I will go over 3 and down 5. This is now my vertex. So now I need to find 2 other points on my graph. We only need to find 2 because we know that they are symmetrical. Parabolas are symmetrical. The important thing is that you use the 2 x values that are next to your vertex. So I know that my vertex coordinate here, my x coordinate was 3. So I'm also going to plug in a 4 and a 5 into my equation from the original one to figure out what those points would be going this direction. So when x is 4, I'm going to plug into my original equation to get what y would be. So now I'm going to replace again. I will say 4 squared minus 6 times 4 plus 4. So that would be 16 minus 24 plus 4. So that's negative 8 plus 4. Y would be negative 4. So my next point here is 4, negative 4. So I can go right here. That will be my next point. And then I'm also going to plug in the next x value this direction, which would be 5. So wherever there's an x in my original equation, I will plug in a 5. So now I'll be doing 5 squared minus 6 times 5 plus 4. So that is 25 minus 30 plus 4. 25 minus 30 is negative 5 plus 4 is negative 1. So my next point is 5, negative 1, which would be right here. Knowing that this point was my vertex and it's symmetrical over my vertex, I can go ahead and complete the other side of my parabola. I now have my points. The important thing to remember also is that this c value is your y-intercept. So you will need to make sure that that point, 0, 4, is where your parabola is going to cross the y-axis. Now since it is symmetrical, that would actually also be right here as well. So you can now connect all your points to make a U-shaped parabola. Hopefully yours actually makes it through all of your points. And there's my parabola. So reiterating what we just did, having a b value here affected where my vertex was. So this is our special equation. It's called negative b over 2a. That gives you the x coordinate of your vertex. In this case, we got 3. I can plug that back in to get my y value of that. 3, negative 5 was my vertex. To find the next few points, I just pick the next x values that are around my vertex. So since x was 3 here, I picked 4 and 5. I plugged in both of those to get the next points. Since it's symmetrical, I could fill in those points. Lastly, you need to make sure your graph crosses the y-intercept where it says to. In this case, ours was 4. So at this point, go ahead and pause the video and follow the steps we just did to try the got it, and then check again to make sure your answers match. All right, so in checking your answer for the got it, you should have got your vertex to be 2, 2. Now be careful on this problem because a is negative 1, so check my work when you are plugging back in for y. You should have negative 1 times 2 squared, and remember order of operations, that would be 2 squared, which is 4, times negative 1. So if you need to go back and fix your work, go ahead and do that now. If you got your vertex to be 2, 2, great. Now, because my vertex is 2, 2, I'm picking 2 more points, so I just picked 3 and 4 to plug in since those x values are next. I plugged in 3 and 4 and got my next points, 3, 1, and 4, negative 2. So I graphed those here. Since it was symmetric on the other side of the vertex, I put those here, and that happened to also be my y-intercept. Remember, C was -2, so that's exactly what I wanted it to be. And I did label on here, so this is our vertex, and that's our maximum. So if you did not do the got it correctly, this would be the time to pause, go back, and then check again.
Okay, if you remember from our 9.1 lesson, we used the equation of -16t squared plus c to find the amount of time that it took an object to fall out of a tree, like when we were dropping the acorn. This time, for our problem that we're going to be using the equation of -16t squared plus v times t plus c. This is talking about if we throw something up into the air and it has no additional force on it, that is the equation that something is going to be rising and then falling to the ground after that. So the problem that we're going to be working on right now is, it says, during halftime of a basketball game, a slingshot launches a t-shirt at the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second, and then the t-shirt is caught by a fan at 35 feet above the court. We want to know how long is that t-shirt going to take to reach its maximum height, and then we want to know what is that maximum height. So again, that's going to be talking about the vertex. And then we want to know what is the range of the function that models the height of the t-shirt over time. So we're going to find our vertex first, so we need to use the equation of -b over 2a. So we're going to go -72 over 2 times -16. Again, that's -17 over -32. Plugging that into your calculator, you get 2.25 seconds. So our x-coordinate is going to be 2.25 seconds. And so that's how long it's going to take to get to its highest point. Then we want to know the y-coordinate for it. So we're going to plug that 2.25 back into our equation. And again, that's something that you can type into your calculator because it does have decimals. We don't expect you to know how to do that. And when you plug all that in and solve it, you get 86. So that is going to be your y, which means that it's going to be going 86 feet in the air. So it'll take 2.25 seconds to reach 86 feet in the air. That's the highest point that it's going to reach. Okay. Then the next thing that we want to know, again, that answers our maximum height. The next thing we want to know, what is the range of the function? And notice, remember, our range was our y values before. And before, we'd always say if it was a maximum, we would say y is less than or equal to whatever our value. Well, this one's going to be a little bit different because, as you notice, we're shooting the t-shirt 5 feet off the ground. So the t-shirt will never go lower than 5 feet because the t-shirt is caught at 35 feet above the court. So our range is going to be anywhere between 5 feet. So we would go 5 is less than or equal to h, which is our height, which is less than or equal to 86 because that's the highest point that that t-shirt is going to reach. Okay. If you want to go ahead and pause it now, you can go through your got it problem. Again, you're going to use that same equation of -16t squared plus, this time it will be still 72t, and then you're going to be finding the next one. Or I'm sorry, not 72. You're going to use 64 for your b on this one. Okay, hopefully when you went through your got it problem to solve for your t, which again is your time or your x-coordinate, when you plug it in, you got 2 seconds. So it's going to take 2 seconds for the t-shirt to reach its highest point. And then if you plug that 2 back into your equation, you would get for your h or your y, your height is going to be 66 feet. So it will not go quite as high as the problem before, and it's going to take 2 seconds to reach its height of 66 as your vertex. And then when we want to know our range, what is the possible heights of that t-shirt at any given time? Again, we're launching it at 5 feet above the ground, so 5 feet, anywhere between 5 feet and 66 feet with the highest point. Okay, so now again, this is where you can write your questions that you may have over the lesson that we can answer tomorrow in class.